Yes. Welcome again. I want to tell you something about Mustafa Şirin. I want to read some of his resume, which is very long. Mustafa Şirin is a mechanical and mechatronics engineer, and he studied at Fazilet College, where we studied together from 1992 until 1998, but he came a little bit later in 1995. So we studied until 1998 at the same school. After high school, he studied mechanical engineering in Middle East Technical University from 1998 to 2002. After that, he got his master's degree from Istanbul Technical University on mechatronics engineering. And his thesis was behavior-based fuzzy logic control of a mobile robot with non-holonomic constraints. This is English, but I cannot say that I have understood all of it. Anyways, so he has had lots of job experiences as an engineer, and right now he is the research and development chief of Kanca El Aletleri ve Dökme Çelik. And I know that there are some students who are interested in the defense industry, and I can say that, I must say that Mr. Şirin worked in the project Fırtına Howitz, the artillery truck, you know that, and maybe he will mention about this later on. And then he even has a patent himself. So I think that's enough for you can ask lots of questions about engineering and what he has had as an engineer at home in Turkey and abroad. Mr. Şirin, welcome again. And how can we do this? Will the students be able to ask questions during your presentation, or will we do it at the end of the presentation?
Yeah, sure. So first of all, thank you, my dear friend Rüştü. It's an honor for me to speak with your students and your colleagues from school. And I think there are also some other friends of us joining. So in fact, there are many things to talk about. I told that this will be an engineering voyage, an engineering journey. So before talking about myself, I want to also talk about some general information about engineering. And then if we have time and if the guests have interest, I can also continue with my own experiences. And always you can stop and ask questions. I would like it to be an interactive speaking. So you can ask questions and you can make your comments. And you can direct me also during the presentation. I can answer as far as I can do. So yeah, how many we are? 30 participants.
Right now we have 30 participants, including us.
Now,
yes.
I will share my screen and make a small presentation. I hope everyone can hear me good. Can you?
We can hear you pretty well, and we can see your screen right now.
Okay. So I told this an engineering as Mr. Türker mentioned, there may be some people in you one who wants to be an engineer, who wants to work in some technological fields. So it is better to know, and not only for the engineers, but also for every one of us, the engineering and technology today is very important. So I think we need to know, we have to know how it started and where is it going, because it's about the life itself.
Right.
So yeah, I'm a mechanical engineer from Middle East Technical University, and I have master's degree from Istanbul Technical University in mechatronics. And the thesis you have mentioned, I just put it down here. It seems a little complicated, but maybe I can say that behavior base is a type of control that you use in robots. You have you like download behaviors to robots.
Nice.
In a short saying, fuzzy control is also a type of control that everything is not very strict. You have a fuzzy mind. It's like blur. It is in fact, this is how the human and also how animals brain works. It's not very strict. It's always fuzzy. It's not only 1 and 0. And mobile robot is a robot
not black and white.
Around,
there are gray areas that are in the middle.
Yeah, there are possibilities. There are some probabilities. Everything is not certain. You can be sure about something 90%, 80%, or 50%. So it is fuzzy. That's why what we call fuzzy.
So it's a kind of different version of tevekkül.
Version of what?
Tevekkül. You know, tevekkül.
Yes.
Yeah, we cannot be sure for the future.
Yes. Yes, it's like that. And a mobile robot is a robot that moves around. It's easy, you know. And holonomic constraints is a physical constraint that it is not good to explain here. It will take too much time.
Okay.
So it's mainly about making a robot that can move around freely like an animal. Yeah. Who has behaviors and also emotions. So what I did during the university is I was the member of the robotic club that was the first in Turkey, who started all these robotic contests and hobby robotic issues. We were the only one, and we were just learning by doing everything. There was no such books or websites around, so we have to learn everything by doing ourselves.
Way before Technofest, you were organizing contests.
Of course.
Right. Okay.
Yeah. Yes. It was the first one, and there were only 2 robots in the first competition. Then I started the robotic website, robotokulu.com. That's also the first one in Turkey.
And it's still active,
It's still running. Yeah. When I have some time, I'm trying to always add something on that. And I have also the Facebook webpage for robotokulu.com and also the YouTube page. So I'm time to time adding some information, some videos and news about robots. You can follow it if you like to receive some latest news about robotic issues and new technologies. So in the industry, after the school, I started doing master's thesis and also started working in the automotive industry, in fact, making some steel parts of automotive. And it was including also robotic and automation. Did a lot of projects in automotive and still doing that. And I also did some international industrial investment projects, which are some production facilities, sports facilities, and different things. I don't go all of them here, but you can ask always. And I also made some robotic designs and consultancy to various companies here in Turkey and abroad also.
Wow, we've got students who are interested in robotics. So I think you'll be hearing a lot of questions about it, I hope.
Okay, good. I can talk about the projects I've done, maybe if someone asks, maybe after this presentation. So let's start with the modern times. So before the modern times, we had, of course, some techniques, some issues that are relating us to the past. Still now, we still have some behaviors or some tactics, some techniques, some technologies from the past. What we call modern times is, I can say, before the industry. The modern times means the industrial times that we can see from old videos or something, like we know better. But before the modern times, there was the human only and the human power. What we call manpower. Now we are counting the some works, some load works with manpower. That time you were using hand tools, chisels, hammers, saws, some simple tools, hand tools, and that still we are producing in the company that I'm working for, Anja. In fact, started with making hand tools also. Let me show you, sorry.
So these were the very first examples
now
of engineering, right?
Yep. Let me take this down. Yeah, for example, these were very old hand tools. You can see they were used in different places and different times for making some carpets and some barrels, some different, you see. They are a few hundred years old, but we are still using these. We are still making similar things.
So if we are still using them,
currently we are making mostly this as the hand tool.
If we are still using them, can we say that they are kind of a masterpieces because the design is still in use?
Yes, the design is still in use with some different changes. Yeah. So some fundamental things don't change.
Right.
Even if we are in very high-tech industry, we are still using similar things. You'll be surprised when you see, this is a museum, by the way. We have a museum in the factory, which we are collecting some different hand tools from, mostly from Turkey.
So is it open to public visit?
So let me go on. Not yet. We are just now showing to our customers who are visiting us because it's inside the factory. Nice. But after the inventory finishes, we will open some in somewhere open to the public. It will be a hand tools museum. It is also during the registration now. It will be registered in the government also. So it will be an open museum. An industrial museum, that's what we call. Yeah. So let's go on. We had horsepower, you know, all the cars, automotive cars have so much horsepower that comes from this ancient habit of us using animals as power source. At that time, we had cars, carts, wagons, which are pulled by horses or other animals. And I will tell a short story here. Do you know the train has two metals and it runs on these two metals, right? Do you know the distance between them, these metals, these rails? Does anyone know it? I already wrote it down here. You should say.
Okay. So the number comes from the same difference between the horses'
yes,
tires, let's say, wheels.
Yeah. This is a famous story. This 143.5 centimeters, and it is not really 5, it's also some decimals more. It comes from the horses, because when the horses are going on the road side by side, two horses have a distance as 143.5, and this way the horses make by their feet is used by the wheels of the carts. So the builders of the carts make it use this distance for the travel to be more comfortable, and they use the same tools to make also some more advanced cars. Like when you start to build the cars with motors, with engines, they had the same wagons, they have the same tools, so they use the same workshops, same people, and they use the same distance also.
They worked on the same platforms.
On the same platforms, and then came the trains, and then came the trains with the same distance again, with the wheel distance, and then they make the tunnels according to this size of the trains, you know. And during making the rockets in the first time, when mankind wanted to go to space, they had to build big rockets in somewhere and carry it to the launching site because it was a distance. And during this travel, they have to use trains. And these trains were going through tunnels. So they have to design the size of the rocket fitting to the size of the tunnel and the train. So it is all connected to the size of two horses side by side.
Oh my God. That's a very surprising story.
Yeah, because they wanted to make it bigger to be more effective, but they couldn't because because two horses are not bigger.
Oh, I see. Interesting.
So let's move one step more. Then we started to use the water power, which is the water mills. You know, we were making floors with the water mills, and also we were using it to shape metal. I will show you one video now. Yep. For example, can you see this one? Just a moment.
We'll be seeing it in a moment, I guess.
You'll be seeing it, yeah.
Yeah.
So this is a very big hammer. It is, you see, there's a metal here, which is like 1,300 degrees. And this hammer is hitting this metal, most probably iron, to form it. So they make it thinner, maybe they make it a hand tool or a sword or something. And this big hammer, when you go back, you see there's a big wheel turning at the back. So there's a river here, and this river is turning this water mill. And this water mill is rising up this big heavy hammer and dropping it onto the metal. That's forging, what we say, hot forging. And we are now in Kanja, we are now making hot forging. Of course, not with these water mills. We have more technological equipments like hammers, which are powered by air, and also presses, which are powered by electric motors.
Are there any workshops using this method today?
This one, no. This is very old, ancient, just to show, but the principle is same. You drop a very big weight onto the hot metal.
I see.
So this is how people use the power of water. I'm trying to open it. Just a moment. Up here. And sorry, no, let's come to the same. Yeah. And in those days, the water was used also for some different things. Maybe you know Al Jazari. Does anyone know him?
We visited the museum
this one.
two years ago. right?
Yes.
But not with
And this
these
is the book.
students. Maybe there are some students who visited the museum, the Cezeri
Is
Museum.
there anyone you who visited the museum?
Yes, I visited the museum.
Okay, how was it? Which one? Which installation do you remember? Which one did you like the most?
I like elephant clock.
Yes, that's the famous one. Yeah. And this Al-Jazari was in 1200s. He was like an engineer. There was no engineer at that time, but he had many knowledge and a workshop, and he was making some what we call automatic things, we can say, using water and air pressure. At that time, of course, there was no electricity like we know today, and there was no controllers, but he was using these water and air and some physics to make some smart, I can say, smart things working. Like
there were some algorithms, right? Yes. So it's not artificial intelligence, but you know, he could kind of program the machines.
Yeah, by using the water, like sorry, I have to drink water. So if you have a opening here, it will drop slowly, and the weight of this glass will drop. So if it is balanced with another leverage or something, then it will be moving like that by time. So Al-Jazari mostly used these kind of movements to control some other mechanisms, like moving arms, and he also used these water mills for moving arms, making some noise, and he used some heavy balls falling from above to move some mechanisms. He was genius at that time, and he started. I think he started the robotics in 1200s.
Father of the robotics. Huh?
Of course, in those times before the modern age, in the literature, Al-Jazari is not very mentioned, in fact. I think this totally false, because this literature is originated from Europe and the United States mostly. And they don't count Al-Jazari, or they don't know, maybe, I don't know.
They want to ignore robotics. I think.
Maybe they say robotics started with some Greek scientists making birds, small toy birds to fly with steam or something, but there's nothing controlled in that. That thing told in the literature is just steam going out from something like a closed glass, and there's no control in that, in fact. So it's not in any way smart. It's just a moving thing, like you fill up a balloon with air and then you let it go and it goes. So there's nothing compared to what Al-Jazari has done in those times.
Right.
I think Europeans have given him another name, Averroes or something like that, like Avicenna. It's okay.
So he's famous with another name.
Another name,
Avicenna
yes.
Is Ibn Sina.
Yes, I said like it.
Avicenna
they have given him another
Sina.
name.
Yeah, I like it.
Yeah,
maybe. But yes, even though they don't mention about him, I have made a lot of literature research, and they don't mention about him, although he's very talented and he made very important automatic working things.
Selami Çalışkan did a great job with opening such kind of museum, right? The owner of the Cezeri Museum, I want to say that he graduated from the same school we graduated from.
Yeah.
So he did a great job for that.
Yeah, in fact, what he did, his father, in fact, is a Durmuş Çalışkan. I have met him. So he has made long years of research about Cezeri, and the Jazari has some books, Kitabul Hiyal, and some others. So there are some sketches inside the book, and Mr. Durmuş Çalışkan has worked all these sketches, and I have visited him also in his workshop.
Wow.
With two other guys. He was trying to make these sketches alive, but it was not easy because sketches were not complete for some of the works. So he had to improvise and he had to solve these sketches, and he made a very wonderful job in this museum and also in this book. But unfortunately, he couldn't see the museum. He passed away, I think, 1 year earlier. Yeah. So his sons have done it very well. And about Avicenna, I will tell you one story. One thing I have lived. I was in Italy, I think. I was there for a business trip. And during that business trip, we were guests and they were taking us to some important places around. It was somewhere close to Venice. And they have taken us to a school, a university. There was an auditorium in the university. In the past, auditoriums were used to make surgeries, to make operations, medical operations. In the auditorium, there are very high seats. Everybody is watching the stage. And in the middle, there's a bed that a cadaver or some people are lying down and doctors making operation. And everybody was watching. And they say this was very important in Europe. It was the first something they did, the first operations, first that, first this. And when I was going through, I saw a book of Avicenna. So they were using, in fact, the book of Avicenna, and they were learning from him, and they were making it first in Europe. So as you said, they maybe are ignoring what has happened in our side of the world. They say everything has just started when everything came to Europe. They take the 0 point from there.
Right.
Okay,
civilization is not something like that,
yeah.
Right? Every culture, every nation put something on it.
Yes. Yeah. Okay. Any questions about the times before modern times? No questions?
So they are waiting for the modern times, I guess.
Okay, let me put it here. So after that, there came the vicious circle of needs. So people wanted to produce more for their needs, and they needed more to produce. What more? They needed more sources to produce. So this was a vicious circle, which is still valid, in fact. They need more production because they have to transport these productions. They have more resources for transport and more resources for production. More resources means more coal, more iron. Energy. And then they transferred it again to more tools, more products. And this was going on and making a continuous circle, which then resulted with ships for transferring the goods and transferring the coal also, mostly in England. There were many coal mines and there were many iron mines, so they want to transfer this with using water channels. We don't have this in Turkey too much, but in Europe, in England, in Denmark, in Germany also, inside the Europe, there are very big, very long water channels. They are like the railways. They are using ships inside the continent very efficiently. We are not using ships inside our
Are they man-made channels or just nature?
Mostly, yeah. In fact, there were rivers, but they enlarged the rivers. They made some connections between the rivers, some levelings also. So most of them are artificially made, man-made. This was making this channel increased a lot their knowledge about construction and physics. It was very important making these water channels because it means money, and it also started to accumulate money in some companies, some people, and they have to build bridges. Then they learn how to use iron, how to produce long bars, how to connect them, how to make calculations about the carriage, the weight of bridge. It was not easy. A lot of people died before making correct calculations, you know. But they learned it by time. They learned how to build things with steel, with iron. And then came the railroads, where there is no water channel or no river or whatsoever water or something, sea. They started to make railroads. And it was also a very profitable business. Most of the families we know today, like Rockefeller and so on, they started their fortune with railroads and bridges and water channels. This was very important. All started mostly in England. And there it spread it all over the world. At that time, these railroads and water channels were not made by countries, not by governments. All were privately owned. Some people started making small investments, then they learn how to do it, and then they sell it to other countries, also to Turkey, to Ottomans, everybody bought from these companies, not the governments.
Now they're way bigger than the governments.
Yes, they are. So here, more resource, using more coal and more iron brought the steam power. And more production brought companies, factories, employers and employees, and investments, and rich families, you can say, which are still rich today. And more resource, also the search for more resource, brought new systems of life like imperialism, communism, capitalism. These things are also coming from the need of resource. Especially imperialism at that time. You know, you have mentioned I have been in many countries and also in Africa. In this imperialism is still going on, and maybe if we have time or some other time,
they are still stealing.
Show some. Yeah, they are. Yes, it is not finished. This imperialism is not finished yet. We can talk about this also if we have time or in other days, or we'll see. Do you have any questions here? Anything not understood? Okay, I'm going on. So the steam engine came on the stage. I have a question here. What is the most effective factor in human life, you think? Not you, Rüştü, but to your students. Okay. I want some students to talk.
I've got no idea about it.
Yeah. Let me give you a hint. Climate, age, I mean, Stone Age, something like that, the modern age, or civilization, or religion. No comment? Yeah?
Good and bad. If we say good, the employees for useful engine factor, but if we say bad thing, I think some factories don't, how can I say?
Are not good for human life, you say. Is it?
Some people don't work because factories use humans work.
Yes, they use humans. We call it, they abuse humans. They use them in a bad way.
Yes.
Yeah, that's yes. In the beginning, of course, in the first times it was very worst. Now in these times it is becoming better, and we'll talk about that also.
It's just
but I am
shape shifted. Now it's still modern slavery.
Yes, modern slavery, but we have some difference. It is still modern slavery, but we have still some difference from the past. When the first factory started, let me say here, when the first factory started, it was really, they didn't have any rights. They didn't have anything.
The workers,
even now,
you mean, right?
If you, yes. Even now, if you go to China or in India, I have been in India also, they just work and sleep in the factory and wake up and work again and then sleep in the factory again. So it's not a good life, I can say.
Being a robot is better than that.
Yes, maybe. Yeah. So I want to tell something different.
I have
here.
a guess. All right.
Yes, please. Yes, please.
I'm sorry. The Industrial Revolution affected humankind very effectively.
Yes. Yes, that's right.
That's the factor.
So if you look at the world population throughout the history, you see from like 7,000 years before, of course, these are some calculations and some estimations, but in the new Stone Age, the Bronze Age, the Iron Age, the Middle Ages even, the slope is very, very small. The population is increasing, but in a very, 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 very small, small angle. And even if you look at the time of Christ here, Hazreti Isa, it is like maybe 200 million or something overall population of the world. I mean, when you look at Muhammad alayhi salam's time, it may be 3 or 4, not even 4. It is like 300 million or maybe maximum 400 million people all over the world. And in
what happened then? The population is
you
just
see here.
popped up. Yeah.
You see here this ramp up very quickly after this modern age. We say when we look closely here, we will see that. Sorry, I will put you here, Rüştü.
No.
In 1800s, exactly, there is a ramp up starting. And it is the, sanayi devrimi. I forgot to translate this one. It's the Industrial Revolution. Yes. Sorry. And at that time, we have the steam engine.
So you mean that people could reach the sources easier? And
in fact, yes, they could reach the source easier, and they were the source itself also. So that's why they were also cultivated. Factories need more people and more consumers, and more production brought easier living standards for people, in fact, because in the factories, things were produced in a mass production way. So it was cheaper and quantitatively more. So people could reach the products easier, yes. And their life also became easy to maintain. Maybe not comfortable, but easier to maintain.
When comparing to the previous ages.
Before the modern ages. So it is this vicious circle I'm talking about. It's still in this vicious circle. The humankind is also inside that. They are also feeding easier, and they are also the resource, so they need to be also more in number. So this was a very effective factor in the human population, as you see, is industrial revolution. It was the first one, of course. What happened there? The control theory has started with Maxwell in 1868 with the steam engines. Of course, steam engine is not invented by Maxwell, but what he made is something different. Let me show you. So when you have the steam engine, then you don't need to be nearby a river because you have your own source of energy, source of motion. You can put it in a train, you can put it in a ship, you can put it in a factory which is far away from sea or river. You can put it anywhere.
Freedom.
Yes, you can carry your energy to anywhere. Anywhere you have coal or you have wood, yeah. But this was not, as I said, invented by Maxwell. Before Maxwell, these steam engines were very dangerous. They were exploding. Many people died because of this, because it was not controllable. They cannot control the heat inside the oven. Sometimes it's getting very hot and they couldn't stop it in the time. Sometimes it's very low and they cannot get the enough energy. So what Maxwell did is to put this controller here. This is a controller. This is a mechanical controller. So this thing is turning. When the machine gets more speed, this thing is turning faster, and these balls are weights. It is going away like that, and it is closing the air going into the oven. So it's slowing down the oven. So when the oven slows down, the wheels also slow down, and these weights come back again to this position, and this valve opens again, and the fire gets more air and it gets higher degrees. So this is making it higher and lower and using the speed of the wheels to control the level the heat level in the oven. So it was the first basic theory of control using feedback, because this feedback was coming from these weights here. And also in 1821, there was the first experiment about electric motor. Faraday showed that electric can be turned into motion. So when you turn electric into motion, you don't need steam engine anymore. Also, this was a revolutionary study. This bring the invention of the electric motor here. So what is this industrial revolutions? Now we say we are going to the 4.0, industry 4.0. Do you know anything about industry 4.0? What is that? Any comments from you, from students? Have you ever heard about industry 4.0?
I might guess.
Yes.
I have no
information,
but it might be fully autonomous, maybe.
Yeah, it is. Yes, it is included.
Or I have
Yeah.
no
Internet
idea.
of Things, artificial intelligence.
Yes.
Why?
Yes, many new things. So let's start with the first one. First industrial revolution is the one I have just mentioned, because it is the mechanization and steam power, which is using mechanical engineering mostly. It was the birth of the mechanical engineering. And this is the foundation of the industry engineering. Then came the second revolution. It was the mass production and electricity. We have electric engineers and mechanical engineers then. These mechanical divided to two. There was electric engineers and mechanical engineers. And there was the mass production. You know, the Ford company, who is making the first mass product cars. He was producing the T model Ford.
And the
Ford Model T, yes. It was the first band type of production. Before that, all cars were produced like one by one. All the workers are gathering together into one compartment, let me say, they were bringing all the tools and all the materials, making assembly, finishing the car and giving away. So it was not efficient. But then Ford came with the mass production method in the cars, and they built a conveyor belt, and all stations, the car was going on the conveyor belt, and all stations making their job. One was putting the head on, one was putting the engine, the next one was putting the wheels, and so on.
At the end of the band, the car was complete.
The car was complete, yes. And you could order any color if it is black. That's one joke that they are doing. All T models are black because the black color was drying out very quickly. That was the main reason. The other colors were not at that time, of course. The other colors were taking too long to dry, but black was drying out very quickly. So they used black to give out the cars quickly. And Ford said, you can buy any color you want if it is black. So then came the third industrial revolution. This includes electric engineering, mechanical engineering, computer engineering, control engineering, and system engineering, what we call to connecting all these disciplines together, and mechatronics also, which is including
you are the boss.
In fact, we are the organizer, I can say, not the boss. Every discipline has their own insight and has their own specialty, the knowledge, the deep knowledge about their field. But when you want to make a system, all these deep knowledges should meet with each other, should talk to each other, and should work together. So someone should be able to know what they are talking about, okay? Because at the end of the fourth year of the university, an electronic engineer graduate and a mechanical engineer graduate, if they talk about their business, they will not understand each other. If they want to build something, it will be difficult to communicate. And if today's machines or today's systems are not purely mechanical or are not purely electronic, so they have everything inside. So someone has to make a design which knows which electronic can be able to do what. I mean, the capabilities of mechanical systems and the capabilities of electronic and computer systems, well, someone has to know it and make a design to synchronize these different disciplines. That's what mechatronics is. So,
teacher,
falsely understood,
Yes, Mr.
Yes, please.
What's the difference between the system engineering and mechatronic engineering?
In fact, there's no difference. In fact, but some use system engineering as more close to the software side, and some use mechatronics more close to the hardware side. But in fact, it is not very, very different.
Thanks.
So even if you are system engineer or mechatronics engineer, you don't know everything in these disciplines. You know, you know some information that is enough to make connection between these disciplines. So,
the mechatronic engineer is like a maestro.
Yes, it's like a maestro. That's perfect. I mean, let me explain one more thing. The mechatronics engineer looks at those different disciplines as black boxes. So you know what is going in, you know what is going out from this black box. Okay.
But you don't know what's going on in the box.
Electric motor in the box. You don't have to know it. Yeah?
You don't have to know it.
Because there are hundreds of boxes that you are dealing with.
Right.
You have what is going inside the electric motor. You have 2 cables, you have 3 cables, you have signals, and what is going out, you know, you have a torque, you have a turning speed. So you have to know this going in and going out, but inside you don't have to know it, but you have to know how to use this one. You have to use this one and put another black box here. This is, for example, control card, and you have to know the capabilities of this control card to drive this electric motor, for example. This is black box technique is the fundamental of mechatronics. So then came the the fourth industrial revolution, the industry 4.0.
Not here yet, right?
In fact, it depends on the companies, the country, and most of the countries, yes, we are not there. I mean, in Turkey, the average, I think, is 2.7 or something here. Even 3 is not very common. Even 3 is a very big investment. Very technological
For
company
Turkey.
is 3. Oh, for world, it is.
For the world.
For the world, it's like that, yes. There are a very limited number of companies in level 3, and level 4 is, I don't know, no one calls himself level 4 yet.
Okay.
But it's, they are aiming it. What is included here is, you said it's Internet of Things, 5G, blockchain, digitalization, AI is artificial intelligence, cloud, machine learning, dark factory concepts. Dark
All
factory,
working together.
Yes. Does anyone know what dark factory is, for example?
I was going to ask about you.
Yeah. Any
It's
comments?
a factory which is dark.
That's
Where
right.
there is no workers.
Because there is no human working inside. You don't need lights. Robots
Just
don't
robots.
need lights. Yeah, only robots working inside. There are some.
So it is literally
like
dark, right? You don't
Yes.
need to light the factory. You don't need
Yes.
lights.
No, just there are some factories like that. For example, the factory of Fanuc, which is making robots. You can see from the internet, from YouTube, Fanuc factory. Only robots are working inside, and they are making robots. So maybe once in 2 hours or once in 1 hour, there comes 2 people going around and trying to see if there's something wrong. They put up the light, and then when they go, they can turn off the light.
Terminator is coming true.
We'll see. So this is the last slide of this subject. Where is it going now? Are we going to a world with no place for humans at all? Becoming a Gaia, let me say. Gaia is a, do you know Gaia? Is the name of this this Isaac Asimov book. You can read it. Is the Foundation series. It's a series of books. In this book, there is a the world is changed, and all the living things in the world are robots, and there's no human. It's such kind of a dystopia telling in these novels. Yeah. Is it a dystopia or utopia we are going to? What do you think?
It's like a finishing all the achievements and walking around the map without doing anything. I mean, if we do all these revolutions, I guess.
Yeah, you're in a game, you're wandering around, but you cannot do anything.
Yeah, you did all the achievements, you complete the main story or the side stories, and there's nothing to do.
Yeah, for example, in this Gaia, there is no human at all. The people are in other galaxies, I can say, or other places, not in the world, doing something else. So what is happening now is robots taking over the jobs. This is what we see now.
So this is reality. This is not future.
Yeah, this is what I'm doing. In fact, I'm every year the systems that I'm building are taking 5, 6, 10 people's job. That's what I do. Yeah, it is all the world. It's like that.
Are you working on education?
They are not just becoming jobless. No, still in the factory, but doing some more.
No, should I worry for my job?
Some people should. Yes.
Okay.
Some people should. We will talk about this, in a short while.
Okay.
So when robot takes over the job, they take repetitive, hard, dangerous jobs. Okay. So when I make an automation, I just look for where the people are working and what they are doing. If the thing they are doing is repetitive, I mean, like always doing same thing, boring, and if it is hard, if they are lifting heavy things, for example, or if it is dangerous, I try to replace it by automation. So which jobs they are taking now is the repetitive, hard, dangerous jobs, mostly. And these people are making some other things. And what will be in the future, what we see, they are taking most of the physical jobs. So in the close future, near future, it will not be just hard jobs. It may be also simple job, but it will be more profitable to use a robot because wages are going up, robot prices are going down. This is a calculation. So most of the jobs will be done by robots. And also some of the decisions will be made by robots or robotic systems or artificial intelligence systems. Even now, they are giving some advices. At the moment, they are not making decisions. I mean, they are making advices and people making decisions. But in the future, most jobs and most decisions will be done by automatic systems.
So you won't need
on the
horsepower.
Other hand, what the people are. Yeah, you will need horses, of course, just to entertain yourself.
No, I mean, you won't need horsepower anymore. You just need brain power.
Yeah, we are coming there. Yes, for the human, when repetitive, hard, and dangerous jobs are done by robots, the lighter jobs are done by people, the workers, and more the jobs which need more education, like higher level jobs, they are done by the workers.
The jobs which requires intellect.
Which requires intellect, yes. Which requires more intellectual capacity. And then they will have more time for planning, for improvement activities.
Yes. Will robots be able to write a poem, make music? They are still making music. They are making music right now, but will they be able to write a poem, make a film, write a novel?
They are making music.
Now
they are making music. I know that. Yeah.
Yes, they are making some, also writing some poets. Not as good as human at the moment, but they are improving. They are learning. Now, one of the important things about artificial intelligence is it's a learning system. You have to feed it with knowledge, and then it learns from the knowledge. But it is important how you feed it, like a child. If you feed a child with bad habits or bad things, he will be a bad people. He will be a bad person. And also training AI with, how can I say, good information is important, or still there are some discussions about that.
The kind of input is important.
Yeah, the kind of input you make is important, because at the moment, people are training the artificial intelligence. they are giving the information, and it is shaped according to the people who is making this training. So it may not be very right every time.
Mr. Türker, may I
also
say something?
Yes, Mr.
Orhan. I think the robots cannot write poems because they cannot feel the emotions. And you cannot, if you cannot feel the emotions, I think you cannot write the poem.
What do you think, Mr. Şirin?
Yes, this is a deep discussion, in fact, going on still in the world of computer software engineers. Now, in the late times, computer and AI engineers and AI system, the people who are working with AI systems are trying to discover what emotion is. As I said, I have made my thesis on behavioral robotics, which includes also emotions. I put emotions in the robotics also. I have behaviors at the bottom and emotions at the top. These are different levels of programming. Now this is also used. And
I think they're kind of trying to create a kind of...
They are compiling, I think. Compiling the emotions
conscious.
of people.
They're trying to...
They are... I mean, what is conscious is the big problem now.
Yes.
So is it something programmable or not? Nobody knows it now. There are many books. For example, yes, I was going to show it to you. This one, for example, Being Human in the Age of Artificial Intelligence. You should read it. It tells about all these issues about artificial intelligence and the consciousness and how it can go in the future about humans and artificial intelligence. So it's a good book to read. Sorry.
All right, we got our screenshots. You can go on.
Okay, I will show you again now. So for the people, there will be more time for planning, improvement, and efficiency. Of course, in the age of fourth industrial revolution, it didn't came yet. We are here now, but it will be here. Let me tell you another thing. For example, I will give you an example about it. Now, in a car factory, let's say Tofaş in Bursa, they are working, the workers are working 3 shifts. So that means they are working like, let me say 8 hours a day, okay? And they are producing cars. And in a good car company in Germany, for example, in Volkswagen, it is also our customer. Both these companies are our customers. So I go inside the factory and make a lot of conversations about people and with the people. So when I go to Volkswagen, they work 4 shifts, okay? 4 shifts means they work 6 hours a day. In the Volkswagen company, there is more automation, obviously more automation than Tofaş. And they are producing better cars and they are producing more cars, but they are working less. How this can happen?
Because of technology.
Yes. This is the extra power they gain from the technology, from the standardization, and from sparing more time for planning, improvement, and efficiency. So if Tofaş wants to stop investing on robots and wants to have more workers, at the end they will be vanished. They will not be able to produce cars in a cheaper way.
So they have to compete. They have to lower their expenses. They want to make profit.
Yes, and at the end, what happens is people are working less and gaining more.
Mm-hmm. So they think they are happy.
That's not a totally dystopia. Yes, people will
it
be happy.
Continue like this?
In the end.
Do you think this will continue in the same way?
What? Yeah, my vision is an utopia. I can say that.
You are an engineer.
Because people will just be working on high-level management, and they will make less work and have the same buying power. Why? Mm-hmm. Because things will be produced by robots, by automation. That's why it will be cheaper. Even if you have the same amount of salary or maybe a little less, mm-hmm. things will be cheaper. So you will be able to buy the same amount or more by working less. So in a factory, you can have 4 shifts, 5 shifts. You can just go for 2 hours a day, work for 2 hours and have the same buying power. You can say have the same
But the
salary.
workers will need kind of more higher education, maybe.
Yes, yeah, yes. Because they will be making more high-level jobs. Yeah. But after this level, I don't know in how many years, but here comes the singularity.
Uh-huh.
Does anyone know about singularity? Have you ever heard about it?
They know the word single.
Yes.
Tekillik.
Singularity, yeah.
Tekillik, yes.
So this is where beliefs, religion is involved in, right?
No. It's not religion thing. No. So singularity in the terminology, it means in the mathematics, if you come to some point that none of the formulas work. Like if you go into a black hole, none of the physics works. That's the singularity for physics. And this singularity here, what we mean is the artificial intelligence. What we call is the general artificial intelligence becomes equal to the human intelligence. So when this happens, you cannot stop the artificial intelligence to be better, because humans don't like to work. Humans sometimes don't like to think, don't like to, improve themselves. But a machine with the same intelligence level as humans will not stop. It doesn't. It is more faster, learning more faster. It has 24-hour time to learn. It doesn't forget.
It doesn't tire.
So it doesn't get tired. So as such thing, I have shown you just as, sorry, I'm looking as this ramp up, you see. The singularity for the mechanical, for the modern age here. The population go on, make a big, and for intelligence, also artificial intelligence, the singularity point is here. After this singularity point, the artificial intelligence will go up like this.
What then?
And we don't know. That's the big question. We don't know what will happen afterward. So that's why all these discussions are going on. Should we make the general artificial intelligence, or should we put a switch to turn it off? Should we make some rules for the people who
there will be some moral issues too.
Issues. Yes, there are many moral issues. But there are many philosophies waiting to be solved. So this singularity is seen, but we don't know when it will come. I mean, the artificial intelligence today is a general artificial intelligence. It is what we call specialized programs. Specialized programs, like you train a program, for example, to read. That's an AI, artificial intelligence program for reading handwritings. That's specialized on that. Or you can make a AI for driving a car, or making an AI to fly a drone, or making an AI for, I don't know, telling what you see in a picture, for example. But these are all some small segments of the general intelligence. It's not like the human intelligence. For example, if there's an AI playing chess, you cannot tell this program to cook some eggs. You can't do it. He doesn't understand. It is specialized on playing chess. But this singularity comes when all these different areas of artificial intelligence are getting together and making a big general intelligence, what we call.
Our toaster will be able to write a poem.
Nobody knows. Yes, then it will be, probably, yes.
Oh my God.
After that, what will happen, we don't know. You can read this book also. This is a story about that singularity. Dan Brown's Başlangıç is a good thing you can read. Or you can read this one, Superintelligence. Yeah. Or you can read also this Rise of Robots. So I'm holding it if you want to take note, or you can read. There are good books telling about that. Or you can read this one also. Geleceğin Fiziği. Yeah. So that's all about this presentation. If you have anything to ask or any comments, I will be happy to answer. Hakan Emre Koç, please.
Firstly, thanks to all these informations they were very useful and really important. I want to ask two questions.
Yes.
Second one is short. Imagine a person who is really interested in engineering, making robots or model planes or such things, but hasn't done anything yet. And this person wants to graduate from Istanbul Teknik University as an aeronautical engineer. Is it too late to be an engineer, or can this person pass his exams with success in university and become a great engineer?
Yeah. So in the university, there are many many options you can you can use to improve yourself. Of course, the lectures are not everything. University is somewhere that teaches you how to learn. Okay, it doesn't teach you how you will be a professional, or how when you become a professional, you will do much more things than you learn in the university. So university is somewhere that you learn how to reach resources, how to make studies, how to make research, and how to learn something. But you don't learn everything in the university, you prepare yourself. And in this preparation, I think things like clubs, like I said, the robotic club, for example, or some other social clubs are as important as the lectures, You have to use these opportunities in the university. Maybe even you should choose the university according to their this kind of properties. So a student who is graduated without experiencing any of these is a very bad job, I think. But it is not late. Always you can learn something if you want. You can spend 1 more year maybe to learn some other things. You can go to some courses, or you can be special. I mean, when you go to the professional life, you will be specialized in some area. You can train yourself about that. But I think only making good grades in the lecture is not everything. It is half of what you have to do.
Yeah, thanks a lot. And the second question, may I ask?
You're welcome.
Your first one.
Yeah. Yes, please.
What characteristic specialties do we have to acquire to be a great engineer?
Okay. An engineer should have a good imagination, I think, because engineer invents and they find solutions, they solve problems. So engineering needs to have good imagination, and sometimes it's like an art to find new ways for solving problems. It's not purely mathematical. Mathematics is just a tool that engineer uses. But I think you should be, you have some art feeling, you should have some social feelings, because also in the professional life, engineer doesn't work alone. You always have a team with you. You have to interact with people. You are going to work with the workers and also with managers. So you need to be able to talk all about all these levels and tell about your ideas. You should be able to explain what you think. So being social is important also in engineering. Some people just think when I do my job strictly, I make my calculations, it will be enough. They think that, but it is not. You have to be able to explain your job, explain your ideas, and also be creative. So you have to, I think, deal with many different subjects related to your profession. Not only one profession, but with some other areas of disciplines.
Thanks a lot. You gave me the answers that I was searching about.
Okay.
Thanks a lot.
You're welcome. You know what I wrote in the in the brochure? Just I wrote explaining myself as a problem solver, as a generalist, and as a managing engineer. So a managing engineer means you have a team, you are talking with people, you have to please those people and they will please you in the job. So you have to have a good communication. You have to know how to communicate, how to interact with people. It's very important. You're leading a team or you're working with people. I wrote generalist because, okay, I'm a mechanical engineer. My specialty is that one, but I also know I am also a mechatronical engineer. Then I also know about electronics. I also write codes. I know software. I know what a control card can do. I can design robots. So I know also in the different areas. I know a little bit astronomy, for example. And you should know a little bit of different things also in this world, in the past, in the modern times, there was only one engineer who knows everything, but it is not possible now. You should know something from everything, but you should be also specialized in your area. Yeah, and the last one was problem solver. So that's the major job what an engineer does. You have to solve the problems by being realistic, by making mathematics, and by being creative and having different ideas. Yeah, I think that's all. Any other questions?
Sir, may I say something?
Yes, please.
In the past, you need to be better from the other peoples, but now you need to be better the robots, I think.
Yes, in some way, it is not possible to be better than robots. Let's be realistic. Robots are far better than humans in some jobs. But you need to improve yourself where the robots or artificial intelligence is not very powerful, then you have to shift yourself to that side. You have to have some new skills, new higher skills. And you have to maybe, for example, I'm making automation systems because I know how they work. You have to know how they work, what they can do, so you can manage them.
Maybe you should thinking like robots.
Think in a way, because you are programming them. Yes, you should be. You should know. I mean, robots are learning everything from humans, so you should know how these robots will act, and you should make your programming according to that. Yeah. Know their capabilities.
All right. So, Mr. Şirin, it's been
so.
Mr. Baru is trying.
There is also one more.
Yes, teacher. I want to be a surgeon in future, but do you think robots will join surgery in future?
Yes, that's one area that automation is going very fast. In fact, there is one robot already in the market for maybe 10 years. It is Davinji robot. You can search from the YouTube. Its name is Davinji surgery robot. And the patent time is about to finish about this robot. So there will be new models coming from other countries. For example, from Japan, there is another coming. So this Davinji robot is, in fact, it is controlled by another doctor, a human doctor. It's not totally autonomous, but it is controlled by a doctor, and the Davinji robot is working inside the body. But these medical applications are in a big rise. If you want to be involved in the medical industry, or if you want to be a doctor, you should better learn about robotics, I can say that, so that you can use these robots in your surgeries.
Yeah, okay, thank you.
And one more thing, yeah. There are also new, what you call, new, for example, if somebody has an accident and his arm is gone, then you make a robotic arm. You can make a robotic arm. These things are coming. People are making robotic arms, robotic legs, robotic some tissues, and robotic organs. They are making it. And in the future, what people are talking about now, these extra organs are more powerful than normal organs. For example, you have two robotic feet that are running faster than your normal feet, normal legs, for example. Then in the future, some people will be willingly change their body. So they will just go to the doctor and they have their arm cut and insert any robot arm because it is stronger. It's this time also will, I think, be closer to this singularity.
Mr. Baru, is there anything you want to tell?
Yes, thanks. I want to ask a question about creativity of artificial intelligence. I think artificial
creativity.
Yes. I think artificial intelligence will not be able to write a poem or novel with creativity because artificial intelligence resources limited with written novels or poems, so it can't be creative or imagine a new thing. So what do you think about this? Thanks.
Okay. Yeah. So I can answer like that. For example, for my thesis, as I said, I made a robot I made a robot programming that is wandering around in a digital environment. And this robot has also a randomness. So sometimes you don't know what it will do. It is deciding randomly. You don't know which side it will go. And if it stuck in somewhere, it cannot go out. If it sucks, this stress level goes up in robot. It's a parameter, the stress level. If it's stuck in somewhere, stress levels goes up. When the stress level goes up, the randomness also goes up. So it starts to move more random. So after one level of randomness, it just finds its way and goes out. So it is without a consciousness. It's just increasing its randomness level to solve a problem. So being creative and yes, is it something coming from randomness? Or is it something in your conscious? Or is it something that you know of, that you have seen in somewhere that what you don't remember? These questions are not answered yet. So we don't know what creates the creativity. It may also be an algorithm you can write down. We don't know it.
Okay.
So a poet, maybe it is not very possible. It is not impossible for AI to write a poet. It will be possible.
Mr. Şahin?
I want to ask a question. For example, I want to make a rocket for technofest. What have to?
We didn't understand the last part of your question.
Yeah, for a rocket.
Yes. What have to I know?
What do I have to know? Yeah.
Okay, you have to know how to make a rocket, and you have to learn it by making a research. Of course, there are many resources in the internet. You can find how you can make the body and how you can fill in the solid fuel inside. There are some chemicals you can make it, and how you put it inside, and there are some calculations that you make because you don't want to make it explode. So in the internet, you can find many resources for that.
Okay, thank you.
All right, and we are planning to...
It's not difficult, I can say that. You can do it.
It's not a rocket science.
Of course, the rockets we are doing is not very difficult, but the real ones going to the space, they are different.
Right. So, Mr. Şirin, I think it's been more than 1.5 hours. Yeah.
Okay.
So it's been a very informative talk with you. Is there anything you would like to add, or do you think we should?
No, I think thank you very much for listening. First of all, it was a pleasure for me also. I hope I was able to tell you something, and I hope that you have enjoyed and learned. So in the first entering speech, you said that I will also talk about my own journey, but we didn't have time for that.
Next time, inshallah.
Maybe in the future, I can. Yeah, maybe in the future I can tell about my own journey, becoming an engineer and going to different countries and having some different adventures, engineering adventures. If we have time again, I would be pleased also.
We are looking forward to it. You helped us to broaden our students' minds. Thank you very much. So, as I said, it's been a very informative talk for me also.
Thank you.
So,
thank you. That's
very
a
pleasure.
Honor for me.
Thank you very much.
Yeah, I just mentioned about some different topics, and you can always go to the internet or buy some books, find some books, as I showed you. And there are many things to learn always. Thank you very much.